Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS College of Arts and Science. In this series, today we are going to discuss about the artificial intelligence and advanced robotics. So advanced robotics combine intelligent algorithm with mechanical system to create adaptive autonomous machines. They enable robots to learn from data, recognize objects and make decisions in real time. This integration allows robots to perform complex tasks in dynamic environments like identifying toys using a camera and AI. So the advanced robotic techniques are object recognition, speech recognition, decision making, neural networks, and artificial personality. So we will see one by one. First, we see the object recognition. So object recognition robot is an intelligent system designed to recognize and classify objects using an artificial neural networks that is called as an ANN. Equipped with a camera, the robot captures image of its surrounding and uses these visual inputs to detect various objects. The ANN, inspired by the structure of the human brain, is trained on large data set containing labeled images of different items. Through this training, the network learned to distinguish between two specific categories. So one is a toy, another one is a non-toys. When an object is detected, the image is processed by the ANN, which determines whether the object falls under the toy or non-toy category. One of the robot key's capability is its ability to function effectively under a variety of conditions, such as different viewing angles and lighting environments. So the robustness is achieved by exposing the ANN to a wide range of image conditions during training, which enables it to generalize and perform well in real-world scenarios. So overall, this robot exemplifies the powerful synergy between computer vision and machine learning, highlighting how AI can be used to create adaptable and intelligent solutions for everyday tasks. Next technique is a genetic algorithm. So it is a controlling a general purpose robot counts is a complex task due to needs for precise movements, coordination of multiplication joints, and adaptability to different tasks and environment. Traditional programming method can be time consuming and inflexible, especially when the robot needs to perform a wide range of actions. To overcome this genetic algorithm are used to enable self-learning in the robot, inspired by the process of natural selections. So genetic algorithm allows the robot to evolve and optimize the behavior over time by selecting the most effective actions, combining successful traits and introducing variation. Through this process, the robot is capable of invention and improving its own strategy for performing tasks, leading to more efficient and adaptable behavior without the need for explicit programming. So this approach greatly enhances the robot autonomy and its ability to handle complex real-world scenarios. Next, we see the natural language processing. So it is one of the advanced robotic techniques. So a robot that understands speech and intent relies on advanced natural language processing to interpret spoken instruction from its owner. So NLP enables the robot to not only recognize the words being said, but also grasp the meaning behind them, including the context and intent to the command. To enhance its understanding, the robot may be use a technique called the fill in the blanks method or contextual reasoning. So this involves identifying missing or implied information in a sentence and using context to infer what is not explicitly stated. For example, if the owner says, put this on the table, so the robot uses the context such as the object being pointed at the known location on the table. So to fill in the blanks and accurately carry out the instruction, this approach allows the robot to interact more naturally and intelligently with humans, making it more effective in real-world environment where commands are often vague and incomplete. So this picture represents the robot understands speech and intent. So the Here the fill the method, we are using the human and the robot conversation. Next one is the operant conditioning. So this is one of the technique we are using the advanced robotics. So a robot can learn safe movements path by using a combination of positive and negative reinforcement within a learning framework such as reinforcement learning. In this process, the robot receives positive reinforcement such as rewards when it successfully navigates safe area or complete desired task. Conversely, it receives negative reinforcement such as penalties when it approaches or interacts with hazardous area like stairs or other dangerous obstacles. So these are in this diagram, operant conditioning is divided into reinforcement. The reinforcement is divided into positive reinforcement and negative reinforcement. Otherwise, it will go to the punishment. The punishment is divided into positive punishment and negative punishment. These are the navigating safely for operant conditioning. So next technique is the decision tree. So decision tree is to find optimal path to go like toy box. So decision tree to take the decision to, if it is yes, it will go in next forward chaining. It will take decision. Then it will go the backward chaining. So next one is the artificial personality. So in this, author says, inspired the author grandchildren, the robot is designed to engage in small, friendly conversation that create a more interactive and enjoyable experience. The robot can respond to simple questions using natural language processing to understand and generate appropriate replies. Next, we see the stimulating emotion. So in artificial personality, we need the emotions. So the robot uses a combination of finite state machine and Monte Carlo modeling to stimulate mood-based interaction, making its response feel more lifelike and emotionally aware. Finite state machine helps structure the robot behavior by defining specific states such as happy, curious, or tired, and transaction between these states based on the triggers from its environment or interactions. So we come to the end of this section. I hope you enjoyed this section. Thank you.